Hi, everybody. We're going to talk about chapter 14 in your book and talk about some of the things that you can do with R to supplement that. And what we're going to do, since we're dealing with two variables instead of one, in our file, we'll have two variables lined up in two columns. And the first one we're going to do is do the brain data. Excuse me. Sorry, that's really rude. Bring in the brain data that we have that's in your chapter, and it's in your file brain1.txt, and I'll include that. And what you're going to do is use something called read.table, and it's reading in two columns, and we do that rather than scan when we have multiple columns. So we have names on each column. That's where we have header equal true. I have a line across the top that has the name of the columns, and one of them has the name brain, and one of them has the name IQ. All right, so I want to plot the brain size versus the IQ, and the brain is the explanatory variable. They used to call it the independent variable, and that's your X, and your Y is the IQ size. So you're going to use the plot command. You put the X variable first, in this case the brain, then the IQ size, and I want to kind of dress up my labels a little bit. I want to have the label of IQ, the Y label of brain size, and I want to have the title of brain size versus IQ. Okay, I look at that and I don't really see anything, but this is a really small sample. So what I'm going to do is I want to have my Y start at 0 and then go to the maximum of the Y. So when I use my plot statement, I start out the usual way with the X and Y. I use the same labeling, but I change the limit on Y. I say starting from 0 and then going from the max, going up to the max of the IQ. And notice you use the C, the concatenate. Okay, well that looks a little better now. So I can kind of see a positive linear relationship. It's not great, but it gives me a better idea of where to look for. All right? Excuse me. Now I wanted to replicate the femur study that they had in your book. So I brought in the femur data. I just put it in a file and brought it in. And I very cleverly used the name femur and humerus. Didn't do anything outrageous. So here we have, I plotted the femur as the X variable, the humerus as the Y, and I used femur length and humerus length, and it cut it off, but it should be, the Y limit is from 30 to 90. And I look at that, and it looks pretty much like it does in the book. So you see the same positive linear pattern. Okay? Now, what we're looking for in these are really a linear pattern. And one of the things that I wanted to mention, they had the GDP with the different countries. Usually when you have those, you'll take the logarithm when you have GDP of so many countries because you'll get that funny shape. All right? Now, the next thing we want to do is sample correlation. And I know you're going to be really disappointed. We're going to use the computer to solve for that and not do it by hand. It gets really nasty quickly. But it's just one function, one statement when you put it in R. So for the brain, you put in the correlation of the brain versus the IQ, and you get 0.377. And they talk about in the book that the R runs from -1 to 1. And the closer it is to the extremes, the stronger the linear relationship is. So this one is somewhat positive linearly correlated. It's not great, it's okay. And then we do the same thing for the femur humerus data. So you use COR, correlation, of femur and humerus, and you get 0.99411 or 414, and this is very highly positively correlated. And one quick comment, you could actually put these in either order and you'll get the same thing. Okay? Hope this helps.